So this is the third video in our series on quadratics, and in the previous videos we've just been looking at manipulating the expressions by factorising and putting brackets into them. Now we're going to use those skills to actually go about solving quadratic equations. And again, most of what you're going to see in this video you should be fairly familiar with. We're going to look at solving quadratics by factorising, using the quadratic formula and completing the square. So, as I said, we've got our three methods: factorising, quadratic formula. There it is, x equals minus b plus or minus square root of b squared minus 4ac all over 2a, and you are expected to know that. And the final one, which is completed square. Now, regardless of which technique you use, I've put that highlighted, but you've just got to make sure that you've got your equation equal to 0 before you do anything else. So you've got some sometimes got some rearranging to do, get it into the right format, and then effectively all you've got to do is then decide which method is going to work best with which equation. And sometimes one will be better than the other, sometimes one will be easier, sometimes one will naturally lend itself to a particular method. Depending on what you want to do, it might be one technique is preferable to another. And again, as with all these things, the more you do, the more you'll get to see or realise which ones are most appropriate in which situation. So, there's three for us to have a go at. So the first one, we've got 2x squared minus 5x equals 42. So that's clearly not equal to 0, so the first thing I'm going to do is put it equal to 0. Simple bit of rearranging. Now I'm going to do some, in this case I'm going to decide to factorise it. And there it is factorised. That's one of the examples that we had in the previous video. And so now I've got 2x plus 7, x minus 6 equals 0. And so we're going to do the solving. And this is what I refer to as the either or bit, because what we're saying is if two things multiply together to make 0, either the first one, 2x plus 7, is equal to 0, or the second one, x minus 6, is equal to 0, which allows us to write this statement and effectively take our quadratic and split it into two simple linear equations. So I've got 2x plus 7 equals 0, give me 2x equals minus 7, x is minus 7 over 2, and from the other one, we've got x equals 6, and there's my two solutions. So that one worked nicely by factorising because it was simple to factorise. So that's why I chose that method. And I would always consider factorising as my first option, and if that doesn't work, then look at doing one of the other two. So we've got our second example, x squared plus 6x minus 2. So a quick look at that tells me that if I'm going to factorise it, I need two numbers that multiply together to make 2. And add together to make 6. Now 2 and 1, I'm never going to get them to add to make 6, so that's just not going to work. So what we're going to do is use the quadratic formula instead. There it is, x equals minus b plus or minus square root of b squared minus 4ac all over 2a. And with all formulae that you use in your examination, it's a good idea to write it down in that version first, so then the examiner can see that you know it and that you're doing the substitution correctly, because if you make a mistake later on, it still might be possible to award you method marks if you've written down a correct formula in the first instance. We've got values a is 1, b is 6, c is minus 2. There we go, so the x squared coefficient is 1, there's a, the x coefficient is 6, and the constant term is minus 2. Plug those in. And when I do this, I always tend to just write down this b squared as, in this case, 6 squared is 36, rather than writing it down as 6 squared. That's just my personal preference. Bit of tidying up, and there we go. We've got our answer, x equals minus 6 plus or minus 2 root 11 over 2. And that, just do the divide by 2, and you end up with the answer minus 3 plus or minus root 11. Now, you can do these on a calculator, so if you've got a graphical calculator with an equation solver function on it, then it's perfectly possible to just plug the numbers in. I'm going to show you how to do that in a second. But before I do, I just need to warn you, it is still absolutely vital that you maintain your skills of being able to do this using the process I've just shown, rather than just plugging numbers into your calculator, because the people writing the exam questions will know you have these calculators available, and they will find ways to be able to test your understanding of quadratic formula so that your calculator doesn't assist you. So make sure you don't just become overly reliant on your calculator. However, you have got them to use, and they are useful, and particularly, let's say, if you want to kind of show working and then use your calculator to check, that would probably be a good way to go. But here we go with the calculator. Now, my students all use the Casio calculator, so I'm going to work through how that one works in this example, but other calculators work in a similar fashion. So, first thing we need to do is pull up the equation solver menu. So from your main menu screen, which you get from pressing the menu or setup button, just scroll down through the first 9 numerical menus until you find menu A, which is the equation solver. And once you've highlighted that, press equals, and you get this screen appear. Now, the equation solver will solve simultaneous equations and do polynomials, polynomials being equations involving squares and cubes and power 4s and so on. So we want a polynomial because we're dealing with a squared equation. And because a quadratic is squared, it's degree 2. So this is just asking us what format we want, and we want a quadratic, so select 2 there. And what you'll get is this screen where it's asking you to put in your values of A, B and C. So clearly all we need to do now is just put in our values of A is 1, B is 6, C is -2. So just type them in, pressing equals after each one, and you end up with a screen that looks like that. Once you've got all those variables in, all you've then got to do is press the equals button, and when you press it once, it'll give you the first value. You can see the calculator screen saying x1 as in our first root, -3 plus root 11, and then press it again, and we've got the second solution, x2 -3 minus root 11. Okay, so that was a brief run through of how to use your calculator. We've got this equation here, x squared plus 6x minus 2, and I said we did it using the quadratic formula. I'm now going to do it using completed square, just to illustrate, firstly, the completed square technique, and secondly, just to show you that you're going to end up with exactly the same result. So, completed square relies on writing the whole thing as a squared bracket. I've chosen x plus 3 squared because this one here is going to give me x squared plus 6x plus 9. Now, because I've got a 6x here, that's why I've chosen the 3. So that gives me the x squared plus 6x. At the moment this is plus 9. I want it to say -2. So what I've got to have to do is take off 11. So now this expression here is exactly the same as this bit here. We've got essentially x squared plus 6x plus 9 minus 11 equals 0. To solve it, all I've got to do now is move over the 11 and do some square rooting. Notice, being very careful, that I've still got plus or minus because I've got to make sure that I keep the 2 roots. So obviously when you do a square root you get plus or minus. That's why the plus or minus exists over here in your quadratic formula. And then the final step, simply move the 3 over and we get exactly the same result that we had from quadratic formula. And finally, we've got one more that I'm going to do, and I'm going to again do it using both methods. But like I said, this one is going to get a little bit more messy, particularly with the completed square. So we'll see what happens when we get to that. So first things first, quadratic formula. There's my formula. Here come my values of A, B, and C. Chuck them in, and you can, like I said, just type that into the calculator or use your equation solver. And there we go, we've got x equals 9 plus or minus root 21 over 10. Let's say that solution is looking a little bit more messy. Let's see what happens when we do completed square. The problem with using completed square for this one is the fact that we've got this 5 at the front. And because 5 is not a square number, it means we're not going to be able to put it inside our squared bracket. So what I'm going to have to do first of all is take that 5 outside. I'm just going to take it out of those 2 terms because those are the ones I'm particularly interested in when doing completed square. So what I do, I use a nice big square bracket to say, okay, I've got a 5 outside. Clearly, if I take a factor of 5 out of here, I've got to have it divided by 5 there. We have that 5 times by 9 divided by 5 is just 9. And I've used a big square bracket because I know in a second I'm going to have another set of brackets inside there. And the key to it is making sure that when I do my completed square inside the square bracket here, I need half of this term here. And half of 9 over 5 is going to be 9 over 10. So, big old square bracket. There's my x minus 9 over 10 all squared. Now, this bit here is going to give me x squared minus 9 over 5x, but we'll also get a constant term on the end as well, and that's going to come from 9 over 10 times 9 over 10. So I don't want that, I want to get rid of it, so what I'm going to do is just subtract that, so 81 over 100 is 9 over 10 squared. So what we're saying is that the bit inside the square bracket here now is exactly the same value as the bit inside the square bracket here. This whole thing here is just x squared minus 9 over 5x. You'll notice the plus 3, I'm not concerned about that at the moment, it's just sitting outside, so I've left that outside the square bracket. So I'm just going to worry about that later on when I tidy things up, which is what I'm going to do now. So now let's multiply out the brackets. So we've got this 5 at the front, so I'm going to do 5 lots of that, 5 lots of the square bracket, and 5 lots of 81 over 100. So that gives me 5 times x minus 9 over 10 squared. There's 5 times 81 over 100. And there's the plus 3 that's just been sitting there this whole time. And the last thing that remains to be done is just to tidy up this section here. So there we go. There's my equation written in completed square form. Now, we've got it in completed square form. We've still got more work to do. What we've got to do is now go ahead and solve this. So let's do that now. Let's just create a bit of room. So first job is to move the 21 over 20 over to the other side. Take the 5 over. Do the square rooting. And then move the 9 over 10 over. And you can see in this case, because we've still got 10 on the bottom of both those fractions, I can just write it as a single fraction. Now you'll notice that I said earlier on that you decide which one is most appropriate to use. And clearly, if you consider the amount of work that we had to do for completed square, clearly quadratic formula seems to be a whole lot more simple and straightforward in this case. Sometimes completed square is simpler to more appropriate to use, and that would be normally in cases where we haven't got this number in front of the x squared. But in this particular case, I think quadratic formula would have been the one to go for.